Hello guys, in this video what I want to do is I want to go over, um, like, basically solving, quadratic equations or polynomial equations by using u-substitution, which is, it's basically you're substituting a variable in and then solving for that variable and then, so this video will show, this is what we're going to go over. So we're going to go over 3 examples like these. And these examples are mostly for trinomials and where there's 3 terms, right? So they're kind of like quadratics, but you're doing something a little bit extra at the end to solve for x. So basically, if we look at the first one, so let me go ahead and copy down the first one. So looking at this one, we have x to the 4th power minus 12x squared plus 27. And of course it is a trinomial. We can use what is called Xbox method, or if you use Xbox method, you can do that, or factoring it by the AC method, right? So the one thing though is, so notice that this here can be rewritten as, we can say x squared and then quantity squared and then minus, and we know that, so we can make u equal to x squared and minus, and then we already know that u is x squared, right? So we have minus 12 x squared and then plus 27 equals 0. Now, if we substitute u in, we're going to get u, so we're going to get u squared minus 12u plus 27. One second, guys. Plus 27 is equal to 0, right? So basically, this is now kind of like a quadratic equation, and we're going to go ahead and solve for u, right? And you'll understand like how this plays into solving for x once we solve for u. This is the better way of doing these. You can't do these, like I said, all these types of polynomials that I'm doing, this does not apply to every like polynomial equation. Mostly ones that look like this. So basically, we're now going to factor this out. We know that a is 1, so we can say, so we now have the equation u squared minus 12u plus 27 equals 0. And we know that this is 1u squared, and then, so we have 1u squared, so that's 1, and then plus, and we have negative 12u, and then plus, and then we have plus 27, right? So plus 27, let me do it in, I'll do it in this color, equals 0, right? So we now know that this is of the form au squared and then plus bu, and then plus c, right? So, and then this is equal to 0. So we know that a is equal to 1, and we know that b, so b is equal to negative 12, and we know that c is 27. So now the AC method, we do A times C, so A times C, so A times C is literally, so A is 1, so we have 1 is equal to 1 times, and then 27, right? And if you don't know what this method is, you should go back to my other video about factoring quadratics and solving by factoring. So basically, we have so we have A times C, which is 27, right? This is 27, and then we need two numbers that multiply to 27 and add to B, which is negative 12. Add to negative 12. So when we do our factors of 27, we have 1 and 27, we have negative 1, and then negative 27. We have negative 3 and negative 9. So looking at these three, we know that negative 3 and negative 9 add to negative 12 and multiply to 27. So now what we can do is, because A is equal to 1, we can simply write u squared minus 12u plus 27 as the quantity u minus 3 times u minus 9. And now we're going to set both of these equal to 0. So, using the zero products property, this means that u minus 3 equals 0, or u minus 9 equals 0, right? So then, this becomes, so this one, we add 3 to both sides, of course, and this becomes u is equal to 3, and then we add 9 to both sides over here, and we get u is equal to 9. Now, these are not our final answers. Remember that we said that u was equal to x squared, right? We said it over here. So we know u equals x squared, and so then, so we know u is x squared. So that means that because u is 3, we're going to have 3 is equal to x squared. And then we're going to have, and again, we're going to have 9 is equal to x squared, right? Because that's literally what u is. U is x squared, so we're just literally substituting it in for those two, right? So then we solve both of these equations by using square roots. So taking the square root of both sides here, we get x is equal to, and we have, so when you take the square root, you always do the plus or minus rule. So plus or minus the square root of 3, and then we have x squared equals 9. So we take the square root, and we get x is equal to plus or minus, and then the square root of 9 is plus or minus 3. So your solutions, so our solutions for this equation are x equals the square root of 3, x equals negative square root of 3, x equals 3, and x equals negative 3. So these are our 4 solutions for this, this equation, right? And also, guys, I meant to say plus here, not, I meant to say that, not minus 2. So we're going to do the second one. So that should be number 2. And so we just did number 1. So this is what we got for number 1. And now number 2. Let me go ahead and write it down. Okay, so let me go ahead and write it down. So, all right, so this is the second problem. Yeah, so And so this is the second problem that we have. We have x plus 2 quantity squared plus 2 times x plus 2 minus 3 equals 0. Now again, look at what we have here on the inside of the parentheses. We can use u-substitution to solve this, right? So if I let u equal x plus 2, right, I can say the following. So I can say the quantity u squared plus 2u, 2 times u, minus 3 equals 0. Now, this becomes u squared plus 2u minus 3 equals 0. So again, we need to know a, b, and c, and we would solve this by factoring. So a is equal to 1, so we have 1u squared plus, and then we have do 2u, and then plus, and then we'll do negative 3, like this, equals 0. Now, this is of the form au squared plus bu plus c equals 0. So that means that a equals 1, b equals 2, and c is equal to negative 3, right? So we're going to use the AC method again. So we know that a times c, so a times c is literally 1 times negative 3, right? So this is equal to negative 3, and we know that b is 2. So we want two numbers that multiply to negative 3 and add to positive 2, right? So we have negative 3 like this, so we have negative 1 and 3, and we look at it, and of course 3 minus 1 is 2, right? Because they need to add to 2. So negative 1 plus 3 is 2, and negative 1 times 3 is negative 3. So because the leading coefficient is 1, you can literally add like just write it the following way. So you can write it as u minus 1 times u plus 3 equals 0. Now, this will give you the following. So you use, again, zero product properties. So u minus 1 equals 0, or u plus 3 equals 0. Right? So then you solve both of these for u. You add 1 here on both sides, you get u equals 1. And then you subtract 3 on both sides over here, right? You get u equals negative 3. So you have u equals 1 or u equals negative 3. Now again, I made u equal to x plus 2. So that means that, so I said u equals x plus 2. And we know that we can substitute u equals 1 and u equals negative 3 in for u, and then solve for x. So this gives us the two equations. 1 is equal to x plus 2, or negative 3 equals x plus 2, right? So then doing that, we have, so we can solve both of these for x. We subtract 2 on both sides, we get x equals negative 1. And then here we can subtract 2 for x on both sides. Hold on. Subtract 2 on both sides. And then we have -5 is equal to x. So your solutions are x equals -1 and x equals -5, right? I believe that's what it is. Hold on. U equals 1. U equals -3 equals x plus 2. And u is x plus 2. Yeah, I think that's what it is. Okay, so that is how you do this problem. Okay, so this one, we're still using u-substitution for this, but there is something that we need to kind of remember, and I will go ahead and, you know, like, there's something that we're gonna have to use. I think it's like either the sum of two cubes pattern or the difference of two cubes pattern. I can't remember, but we're gonna have to use one of those. So the first thing that we're gonna do, obviously we know that this can be rewritten as x, let's see, hold on, it goes x cubed quantity squared minus 7x cubed minus 8 equals 0. If I make u equal to x cubed, I can say that this is the following way. So I can say that this is equal to x cubed quantity squared minus 7, hold on, minus 7x cubed, and then minus 8 equals 0. Right, so then we know that u equals x cubed, right? And we can substitute that in, so we have u squared minus 7u minus 8 equals 0. Now, we can solve this for u. If we so we can rewrite this as 1 u squared plus -7 u plus -8 equals 0. Here, a is equal to 1, b is equal to -7, and c is equal to -8. And of course, this is of the form au squared plus 7u, or I'm sorry, plus bu, and then plus c, right, is equal to 0. So we want two numbers. So we need to know what a times c is, right? So a times c, so let me first write this down. A times c is going to equal 2, and that'll be 1 times -8, right? So this is going to be equal to -8, and then we know that b is -7. So we want two numbers that multiply to -8 and add to -7. Off the top of my head, I know that those two numbers can be 1 and -8, right? So this means that u squared minus 7u minus 8 can be rewritten as the quantity u plus 1 times u minus 8. Now, we know, so you can either do this two ways. You can substitute x cubed back in for u, so this would give you like x cubed plus 1 times x cubed minus 8 equals 0. The thing is that you would have to use something called the sum and difference of two cubes pattern. Now, because we are solving for x, the thing is that we need to find all the real solutions. So we're not just solving for the x-intercepts or like, you know, the roots of x. We're literally solving, I mean, we are solving for those, but like we're solving for all real numbers that x can be, including imaginary numbers or complex. So I need to look up the sum and difference pattern for cubes. So let me just write this really quick. So this would be, so 1 second. Hi guys, sorry if I literally paused the video and then, you know, it's like maybe a day later or 2 days later. So I'm gonna go ahead and finish this problem. So what I basically put here is we have x cubed plus 1 and x cubed minus 8 equals 0. And the main thing that I wanted to do here was to find, you know, to use the sum and difference pattern of two cubes to find, you know, this as well as this, right? So kind of to simplify them, right? So this is the sum of two cubes pattern, and this is the difference of two cubes pattern. So I'm going to use this one to find x cubed plus 1, right? So kind of to evaluate it. So basically we have x cubed plus, and we're going to do 1 cubed, right? And this is going to be the quantity x plus 1, so this, and then times x squared, so times x squared minus so minus 1, so minus 1, and then times x, right? So times x, let me write that down a little bit better, times x, and then plus 1 squared, right? So plus the quantity 1 squared, right? So, and so this is what x cubed plus 1 really is. And so this is x plus 1 times x squared minus x plus 1, right? And like I said, we want to find all the values of this, like all the solutions, including whether they're imaginary or complex. So basically what we're going to do is we're going to go ahead and so let's see here. So obviously we're trying to solve x cubed plus 1 equals 0. And so we know that x cubed plus 1 is this, right? And so we're going to set both of these equal to 0. So that means that x plus 1 equals 0, or x squared minus x plus 1 equals 0. Now, we're going to go ahead and subtract 1 on both sides here. We have x equals negative 1. And then here, I'm going to use the quadratic formula to solve this for x, right? So this would be, so if I say a is equal to 1, b is equal to negative 1, and c is 1, I can say, so I'm going to write down the formula. Hold on. Okay, so this would be negative of negative 1, so a negative of negative 1 plus or minus the square root of negative 1 squared minus 4 times 1 times 1 all over 2 times 1, right? So like this, right? So basically, negative of negative 1, that's 1, plus or minus the square root of 1 minus 4 all over 2, right? So this would be 1 plus or minus the square root of negative 3 all over 2. And we know that this would be 1 plus or minus I square root of 3 all over 2. And so the solution to this is going to be x equals negative 1, x equals negative 1, or I'm sorry, no, x equals 1 plus I square root of 3 all over 2, and x equals 1 minus I square root of 3 all over 2. So these would be kind of 3 solutions to that. Now we need to do x cubed minus 8 equals 0. So we have x cubed minus 8 equals 0. And of course, you would say, so it'd be kind of, so let's see here, it would be, so you would do the difference of 2 cubes pattern, so it'd be x cubed minus, and then 2 cubed. And so this would be, so let's see, it'd be x minus 2, so it'd be x minus 2, so x minus 2 times x squared, and then, so hold on, so it'd be times x squared plus, and then 2x, so plus 2x, and then plus 2 squared, basically, so plus 4, right? So then we would have, so we know x minus 2 equals 0, that's x equals 2, right? And then we have x squared plus 2x plus 4 equals 0. So then we need to do the quadratic formula for this, right? So we're going to do it again. So a is equal to 1, b is equal to 2, and c is equal to 4. And I'm going to write it down. So, okay, so we're just going to plug it in. So we have negative 2 plus or minus the square root of 2 squared minus 4 times 1 times 4 all over 2 times 1, right? So this would be negative 2 plus or minus the square root of 4 minus 4 times 4 all over 2. And so this would be negative 2 plus or minus the square root of 4 minus 16 all over 2. And this would be negative 2 plus or minus the square root of negative 12 all over 2. And the square root of negative 12 is I times the square root of 12. The square root of 12 itself is the square root of 4 times the square root of 3, which is 2 square root 3. So this would be negative 2 plus or minus 2I square root 3 all over 2. Now, we need to factor out a 2 from here. So it would be 2 times negative 1 plus or minus I square root of 3 all over 2. So this would get canceled out. And then we would say that this is just equal to negative 1 plus or minus I square root 3, which is x equals negative 1 plus I square root 3, or x equals negative 1 minus I square root 3. So these would be the other solutions, right? Now, that means that for this function, or this equation, there are 6 solutions. I think 2 of which are complex, or 4 of which are complex, and 2 that are real. So basically, we have, one second. So the solutions, we have x equals negative 1, right? So we have x equals negative 1. So x equals negative 1. And then there's x equals 2. And then there was x equals, so there was also these over here. X equals 1 plus I square root 3 all over 2. So x equals 1 plus I square root 3 all over 2. X equals 1 minus I square root 3 all over 2. And then there was these two. There were these two that say x equals negative 1 plus I square root 3. And then x equals negative 1 minus I square root 3, right? So basically, this would be, so then this one would be x equals negative 1 minus I square root 3. So those are all of the solutions for this equation. And I don't know if, in reality, I mean, if they're just asking for the x-intercepts, like for just real numbers would be just x equals negative 1 and x equals 2. But when they ask for all real solutions, there are really 6 of them, because there's it has a degree of 6. So that is how you do that problem, guys. I think that was it. Yeah. So I do apologize if it took me like 2 days to do this. I literally like paused the video and then I never came back to it. But I did remember that I had paused it, and so yeah, so that is how you do those 3 problems. And so if you guys have any questions whatsoever, please do let me know. And thank you so much for watching, and please like, comment, and or subscribe. Oh, and by the way, happy holidays, guys. For those of you that celebrate Christmas, happy holidays to you and your families. So thank you so much for watching, guys, and I will see you guys in the next video. Bye, guys.